Hello everyone and welcome back. In this lecture we'll try to find out the most common words in our spam in ham. One method we have seen before that the count vectorizer object has is known as the get feature names. We have seen that method to find out how many words we have, right? So for instance what we did was we have our vector object and then we can call the get feature names method on it. Get feature names, and we can save this in a variable. Let's call it xtrain words. Okay, now if we check the length of xtrain words, we see that it has a length of 7125, and we can, if we want to print out any specific words in our xtrain words object, we can simply index it. For instance, we can say xtrain words, and then let's say we want to see the first 5 words, so we can simply index it up to 5. So these are the first 5 words in our xtrain words object, and we can simply index any position that we like. For instance, if we want to see words from index 89 to 100, we can simply index those positions. So these are the numbers, and towards the end, let's say we can say 7000 to 7010. Those are the words that we have. We can also use negative indexing to see the end of, to see words at the end. Another method I want to show you is known as the feature count method. Feature count. We can use this method to find out how many times a certain word or token appears at a given instance. Okay, so we can call this feature count method on our multinomial naive Bayes model. Let's do that. So last time we saved our model in a variable called NB model, right? Multinomial NB model, and we can call the feature underscore count method on it to see how many times a certain word appears. So here in the result we have an array. So the first row represents our ham message, whereas the second row represents our spam message. Okay, and what do these numbers mean? So for instance, if we take this first number, it means the first word or token appears 0 times in our ham message, and it appears 6 times in our spam message. Okay, and if we consider the second word, it appears 0 times in our ham, and it appears 25 times in our spam message. So this is what it is. So this whole object is an array, right? It's a 2 by, we have 2 rows by this number of columns, 7125. To double check that, we can simply call the shape method on it. So I'll call the shape method on our object, and it's 2 by 7125, 2 rows by this number of columns. What we can do now is separate this array rows. We know that the first row is in ham and the second row is spam, indicates spam, right? So if we are to index this array, the first row will be index 0 and the second row will be index 1. So that's what we will do next. We'll index the feature count method and then store the first row in a certain variable and the second row in a different variable, and those variables will represent words in our ham and words in our spam. Let's do that next. So we have our NB model, and then we'll call the feature count method on it, and let's index the first row, right? So that will be 0 for rows, and we'll consider all the columns. Okay, so beginning to end. And let's save this in a variable called ham word count. Okay, and let's do the same for our second row. So our second row will be for our spam message, and we'll save it in a variable called spam word count, and that will be equal to our naive Bayes model, and then we'll call the feature count method on it, and then we'll index the second row, which is index 1, right? And then we'll consider all of our columns. Okay, now if we call ham word count, we'll see a single array. Its shape will be 1 by 7125. So ham word count, run it. So that's our array. And if we call the shape, if we try to see the shape of it, it will be 1 by 7000, right? Single array with 7125 columns. Similarly, if we call our spam word count object spam word count and run it, we have the second row. Now let's combine these two together and create a data frame which will represent ham and spam and a list of words that we have. Okay, and we'll save our data frame in a variable called tokens. So pd.dataframe, and we'll pass dictionary key and value combination to create our data frame. So for our token, we'll use the xtrain words object that we created earlier. So we'll use that for our token, xtrain words. Let me pass that here. Token will use xtrain words, and then for our ham column, we'll use the ham word count object that we just created. Okay, ham word count, and finally for our spam column, we'll use our spam word count. Spam. Okay, now let's see what our data frame looks like. I'll call the head method on our data frame. Okay, we have ham, spam, and token, and we have the first 5 words, right? 0, 0, this is the second word. Then we have that, we have this. So for instance, if we take this 5th token, it appears 0 times in our ham message and once in our spam message. So what I will do is I will set the index of our data frame to be this token, so that token will be our index. Let me do that. So we have our data frame tokens is equal to tokens, and we'll use the set index method, and then we set the index to be token. Okay, now let's check our data frame again. Tokens.head. Okay, looks much better now. Again, these numbers indicate how many times the specific token or word appears either in ham or spam. For instance, this token 000 appears 25 times in our spam. Okay, and similarly, we can check the last 5 rows by calling the tail method, and that's what we have. There's also another method known as class count, and we can call this method on our naive Bayes model, and this will tell us the number of observations that we have in our ham and spam classes. Okay, let me show you that method. We have our multinomial naive Bayes model, and we call the class count method on it, class underscore count underscore, and if we run this, we get an array of this value. So these numbers indicate the number of observations that we have in our ham and spam classes. So we have 3,386 observations in our ham class and 514 observations in our spam class. Okay, what we'll do is we'll take these instances of observations and then try to calculate the frequency of each word in our ham and spam class. And once we convert these observations into frequencies, we'll calculate ham to spam ratio for each of the words. And then after that, we can deduct which words are the most common in spam and which are the most common in ham messages. That's what we'll see in the next lecture. Thank you, everyone.